Now we're going to bring together what we were doing with recursive formulas by writing an explicit formula that represents the sequence that's defined by a recursive formula. So this first one, A, tells us that the first term is 4. The next term is equal to the previous term plus 12. So whenever I see a recursive formula, I always like rewriting it in terms of next equals previous. I didn't see many of you putting that in your work. So if I, instead of doing that, I recognize this is adding. So if that's adding, that's an arithmetic sequence. So I'm going to use that a sub n is equal to a sub 1 plus n minus 1 times d. Again, the d could go in front or back. This is the way the formula shows up on the reference sheet. So no, you do not need to memorize this formula. It will be given to you on any test. So a sub n, the first term they give us is 4, so that's going to go in here, plus n minus 1. And what's the common difference here? 12, because that's what you're adding. That's your common difference. This number right here is the common difference. This is your, the a sub 1 was given. Okay, so now this is your answer. This is the explicit formula that generates the exact same sequence as what was given to you. The next one has that the first term is 28. The next term, we have to take negative a half times the previous term. So because we're multiplying, multiplication means that this is a geometric because this is multiplying. So I could have said this is arithmetic because it's adding. So I'm going to use a sub n equals a sub 1 times the common ratio to the n minus 1. So what am I going to put in for a sub 1? A sub n. A sub 1 is the 28 times, what's the common ratio? Well, it keeps being multiplied by the negative a half. I guess I could have looked at it there, or I could have looked at it here in the formula. You get my point? I could have looked at it here in the formula. Negative a half to the n minus 1 power. So the recursive formula gives you the first term and either the common difference or the common ratio. So then you could use that to fill in one of those formulas. So now let's take a look. I have 4 practice problems, I believe, and then you'll have a delta in class tomorrow. The recursive formula is described in the sequence below. So here's your first term. The next is equal to 1 plus 2 times the previous. State the first 4 terms of the sequence, and then they want to know if you could use an explicit geometric formula. Okay, so let's take a look. The first term is 3. The second term is 1 plus 2 times the previous. The previous here was 3. So that gives us 7. The third term is 1 plus 2 times the previous term, which was 7. The fourth term is 1 plus 2 times the previous, which is 15, which gives us 31. So to go from 3 to 7, 15 to 31, those are our 4 terms. Now they want to know, could we write this using a geometric formula? Well, we know the first term is a sub 1 is 3. Is there a common ratio? So if there's a common ratio, that means I should be able to take the second term and divide by the first term. And I would get the same thing if I took the third term and divided it by the second term. So any term divided by what's ahead of it. So if I take 7 divided by what came before 3, will I get the same thing as if I take 15 divided by 7? And if you put these into the calculator, you'll find that they're not equal. Therefore, there's no common ratio. So cannot use a geometric formula. And you could see that because the recursive formula is not just multiplying, it's also adding. So it has to either just be multiplying for geometric or just be adding for arithmetic. Next one. They give us a sequence written out, write an explicit formula, then use your formula to get the 20th term. So here they've given us a sub 1, a sub 2, a sub 3, a sub 4. In order to write the explicit formula, we need the first term, which is 5, and then we need a common, well, it doesn't tell if it's arithmetic or geometric. We have to figure that out. So to get from 5 to 8, what do we have to do? 5 to 8, we're going to add 3. Will that work from 8 to 11? Add 3. Add 3, yes. So that means because 8 minus 5 is the same thing as 11 minus 8 and 14 minus 11, this gives us a common difference of 3. So if I'm going to use a sub n equals a sub 1 plus n minus 1 times d, here's our a sub 1, here's our d, and we're going to plug it in. A sub n equals 5 plus n minus 1 times 3. So you had to first figure out that it was arithmetic to know to use that one. Now we're going to get the 20th term. Now the thing about an explicit formula that differs from a recursive formula is we don't need to find the 5th term, the 6th term, the 7th term. We could skip right to the 20th term, and that's what makes an explicit formula easier to work with. So to find the 20th term, we take the first term plus, in this case, n is 20, so I'm going to plug 20 minus 1 times 3. So we're going to add 3 only 19 times to the 5. So what's 19 times 3? Too lazy to get the calculator. 57. Add the 5. You get 62. Final answer. They wanted the explicit formula and they wanted the 20th term. Okay. Next one they gave us, the 9th term is negative 2. And then we have that the first term, so this is like f of 1, f of 2, f of 3 they're giving us, f of 4. When there are multiple choice questions like this,